All right, let's take a look at examples 3 and 4 of our logarithmic equations. So we do have two methods here that we will kind of employ here to solve equations that involve logarithms, and they both basically goal is to eliminate the logarithm. One is to get a single logarithm on one side of the equal sign and then just rewrite it in the exponential form. The other is to get a matching log on each side of the equal sign and then cancel them out because they kind of balance each other. So here's an example of each one. No matter what we try to do, if we try to reorganize this equation, move one of the logs over to the other side, this 2 is going to keep us from having just a log on each side. It's going to be a log of 5x equals 2 minus log of x minus 1, which we can't just cancel the logs because of that addition and subtraction with the 2. So instead, what we try to do is take these two logarithms and write them as a single logarithm, which we can do with our properties. We know when we have addition between our logarithms, we can go ahead and condense that with a product. So we'd end up having a log of 5x times x minus 1. Okay, is now equal to 2. That's the product property of logarithms. We have the quotient property, the power property, all those other properties as well. But now what we can do is recognize that we have a product in here. We can go ahead and rewrite this in exponential form, and that should get rid of the logarithm. So this is the common log, which remember means this is base 10 here. So we're going to be able to rewrite this as 10 to the second power is equal to whatever's inside there. So this is going to be equal to 5x times x minus 1. Okay, and then we can just start simplifying. Well, 10 squared is 100. Again, our goal is to get x by itself, or get 1x to the first power all by itself. Over here, we can distribute the 5x to the x, and we get 5x squared, and then distribute the 5x to the negative 1, which makes it negative 5x. And we do not see that this is quadratic. And a lot of these will turn quadratic. We want to watch out these logarithms. A lot of times they'll have one answer that we'll come up with two, but maybe there's only one works. So make sure that we're checking solutions here when we get done. But this is degree 2 now, so we're going to find two potential solutions. We'll see if they both work in the end. And being that it is quadratic, we would want to minus 100 from both sides here to get it set equal to 0. So we get 0 equals 5x squared minus 5x minus 100. I see a GCF in there of 5, so I'm going to try and factor that out first, and then we'll see if we can get to factor down anymore. So each of these terms here divided by 5, so we pull the 5 out front, and then we can now try and factor what remain. That's just going to make that factoring much easier here, but we need to use x and x to make x squared. Factors of 20 are just 1 and 20, 2 and 10, 4 and 5. Of those, I see a 1 out of the 4 and 5, so let's put the 4 in here, the 5 in here. Last one's negative, which means we need one of each. And to make negative 1, we'd want negative 5 with a positive 4. Okay, and there it is. We got it factored out. So set each factor equal to 0 then and solve it. So we get 0 equals 5, x plus 4 equals 0, and 0 equals x minus 5. Solve each one. Well, this one just doesn't solve. There's no variable there, which just means we don't get an answer from that one. This one we can minus the 4 from both sides, and we'll get x equals negative 4. And then over here we're going to add 5 to both sides, so we get 5 equals x. So we have two potential solutions. We want to see if they work. And that's just to do a back substitution. Go back, plug it in, see if it checks out. You could also graph it, but in order to graph it, you have to have it set equal to 0. And I'm going to show you one graph here just so you have an idea of what the logarithmic graph kind of looks like. But it's kind of just a swoosh kind of little format there. And we can see it looks like it's only crossing the x-axis once. So one of these may or may not work. But let's go ahead and check it. I'm going to do the negative 4 first. We're going to store that as x. So again, every time I hit x now, that stores that in there as negative 4. So we get log of 5 times x. Delete that extra parenthesis there. And then we should be able to add to that log of x minus 1. If you don't have a graphing calculator like this, you just plug in the negative 4 for x. And this should be equal to 2 if it does work and checks out. No, it says non-real answer, which tells us, hey, it had a problem. It had to go into the complex numbers to solve this thing. And we're looking for the solutions here where we cross the x-axis. So x equals negative 4 is actually going to be one of those extraneous solutions. X equals 5. Let's see if that one works. So let's go negative, or sorry, 5, store that one as X. And then if we hit second enter twice, it'll bring down what we typed in before. And just hit enter, and now it plugs a 5 in for each of those X's, and we get 2, which is what we should be. So there it is. The only real solution here is X equals 5. This one is extraneous, so it actually doesn't work. It's not a solution to the quadratic, but it does show up when we solve with the algebra.